you work really hard for the whole week to implement this data pipeline, and the last thing you really want is to lose all this work you did. So we need a better way to prevent this from happening. And the best method to solve this problem is to use source control or version control system. The three main benefits we have here are the ability to protect our source code. So we will be storing our source code into a centralized service. We don't have to worry about the source code being lost in a folder that's been hidden away somewhere, or someone accidentally moved it. It gives us the ability to do branching and merging capability. So this will allow multiple stream of work being take place at the same time. So after the work is completed, the code can be merged back into the primary work stream for testing and deployment. Finally, the last primary benefits of having a source control is having traceability. So in other words, it has the ability to able to detect all the changes that code changes that we have and able to track them, and also allow us to see all the previous version of the code, including comparing to the previous version as well as rolling back to the previous version. So in Azure, we have two services that are available for the source control. So there's the Azure DevOps Git repository, and Azure also supports GitHub Git feature as well. So in our presentation today, we will focus primarily on the Azure DevOps. So let's see how the source control is used for Azure Data Factory. So once we have set up the Git integration, and that we are our demo coming up, ADF, our Azure Data Factory, actually splits into two different modes. There is a Git mode, and then there is a live mode. And in the Git mode, on the left side of the screen there, we can see the code will be stored in the Azure DevOps Git repository, as we mentioned. They have a concept called collaboration branch. So a collaboration branch essentially is the master or the main branch that the code is tied to in the Azure Data Factory. And any development that we want to do, we should be doing them in what we call the feature branch to take place. So as you can imagine, this will allow multiple developers or data engineers to work together, work in parallel in their own feature branches. And then once all the changes completed, then we can merge all the changes from the feature branch into the collaboration branch. It is very important that we test all of our code or all of our changes for our data pipeline in the collaboration branch at the end. After testing has been completed, we then need to publish this change by using the publish all button in Azure Data Factory. And what this will do is it will convert all the data pipeline source code that we have, and they're stored in JSON, and the process will convert them into an ARM template and then deploy into the live mode of the Azure Data Factory. An ARM template provides the instructions for the Azure to deploy its resources. So that's including the data pipeline that we have. So, for the demo, more specifically, we will set up the Git integration, as we talked about. The collaboration branch we'll be using is the main branch, which is the default for Git repository nowadays. And as well as for the publish branch, we will create something called ADF publish branch, which will store all the ARM templates. Finally, we will also create a feature branch called work1, and where we will see the work are kept separate from the collaboration branch, and as well as the publish branch in our data factory. So let's jump over to the demo and let's see how we can set this up so we can prevent all the hard work and the week's worth of work so we won't get lost. Okay. try. Okay, sorry about that. Just flipping through the screen. So yeah, so in here, this is our development data factory. As you can see here, we have already data pipeline that that has been deployed from the first part of the presentation. So there are quite a bit of services or resources that are created already in the development of the Azure Data Factory. So the first step for us to do is to integrate with the Git repository in Azure DevOps. So to do that, we'll go under the Manage. And we'll go to Config. And then in here, we'll have the ability to select, like what we talked about earlier, the difference between the Azure DevOps Git versus the GitHub. For me, I'll like I said, select the Azure DevOps. This is just the Active Directory that I have for my environment. And for the project name, I'll select demo. This is the repository that I have, or the project that I have created for the demo today. And finally, the repository name will select demo as well. So as you can see on the screen here, there's a collaboration branch that we talked about just a bit earlier. So in this case, I want that collaboration branch to be main. The publish branch is unchanged, is the default, which is the ADF publish. And finally, the root folder, I want to put all the Azure Data Factory source code into a subfolder in my repository. So I'll just call that ADF dash code. And the last configuration here that is important for us is the import existing resources. So since all the resources we have are currently, or all the data pipeline that we have are currently inside the Azure Data Factory live mode right now, we want to make sure we import those resources or the data pipeline into the main branch of the repository. Okay, so to do that, after that configuration, I'll click Apply. So now Azure Data Factory is going to be generating all those JSON files and copying them into the repository. Is it possible to do this in YAML? So this initial part, no, it is not possible to do it in YAML. Later on, when we do the CICD deployment, we will be using YAML to convert the JSON file into the ARM template, but we will cover that in the second part of the demo. Okay. Okay, so looks like we're able to connect to the Git repository. So the second thing we will do here is click Publish. And what this will do is similar to what we talked about earlier. This is the publish ADF publish branch that we will be publishing to. Yeah, there's no pending changes as we haven't made any changes yet in the environment, which is okay. So we'll click OK to continue. Okay. So just waiting for that to complete. So it looks like all the ARM template has been generated successfully, which is good. Okay, so as you can see here, also we see the main branch is being selected as well on the top here. So this is kind of the main control that that we have in the Azure Data Factory to know what branch we're on. But we'll come back to that in a second here. First, we will go into the Azure DevOps and let's take a look at the Git repositories to see all the code that we have in the environment. So let me do a quick refresh here. All right, so this is the demo repository that we have, and the ADF code folder has been created as we discussed previously. And in here, we can see all the different Azure Azure Data Factory components in here. So we have the 8 or 9 different data sets that we have. We have different link services and various different pipeline and triggers. So looks like everything was copied over successfully by Azure Data Factory. And another key things to note here is those are JSON file as well. Okay, so we can click on it. We can read it if we're interested in knowing the detail of the JSON. So the next thing we will do here is jump over to the ADF publish branch and see how this is different from the ADF publish or the ARM template per se. So we see the structure is dramatically different in the ADF publish. We don't have the ADF code branch. Instead, we have the name of the ADF instance. So in this case, it's the demo dev instance that I have. And we have the ARM template, but they're JSON files. So we can see here all of the components that we have in the Azure Data Factory have been changed and consolidated into one massive JSON file that is in the ARM template format or structure that can be deployed in Azure Data Factory. Deploy using into Azure. Okay, so let's switch back quickly to Azure Data Factory for a quick moment, and we'll take a look about the different controls that we have. So as we spoke earlier, in the Azure Data Factory, now this little drop-down becomes available for us. And we can see that right now it's attached to the main branch, which based on what we set up, we know that this is part of the Git mode that we have. And it's important to note that there's also the ability to switch over to the live mode. And when we do that, we can also see our pipeline are still available in the live mode. And if we switch back into the Git mode, all the pipeline and all the data sets are still there. So so let's create a feature branch. Let's say we want to make changes into our pipeline, right? So we can click on the again the drop down button there again and go new branch. And in this case, like we talked about, I personally like to group all my feature branches together into a subfolder. So I just call it feature slash. And in this case, we'll be calling the branch name work1. The create button is grayed out. Sometimes we just have to reselect the main branch to reconfirm that's the branch we want to create this this feature branch based on. Okay, so we'll click create, and it's created pretty quickly. And just a reminder that this also changes as well to the branch that we are on today. So for this pipeline, let's just say I want to put in a new description. This is a new. Okay, and let's say you want to make a bunch of changes in your pipeline as well, but I just for this demo we'll just go with the description for now, and we can save this change. Okay, so this change is actually only saved into this work1 branch. This change will not be impacted in the main branch nor the publish branch. It's also important to note that the publish button is also disabled in this case because you can only publish from the collaboration branch or the main branch in our case. So we'll go back, we'll swap over to the main branch, and we would expect to not see this description for the pipeline demo one. Okay, so we're on the main branch now. So we swap over, and then there's no description as we expect. Perfect. So now we know the Git workflow is working, and we will just do the one last thing, which is the pull request. So the pull request allow us the ability to merge the feature branch back into the main branch that we discussed earlier. So when we click on it, we're given the options in the Azure DevOps to merge the code back into whichever branch we want. So for us, we want to merge the new description for pipeline one from the work1 into main. So update just gonna click and demo one, for example. Now I can create this pull request now, and when the pull requests do get completed, let's say after code review and so forth, we will be seeing this coming up in the main branch. But for the purpose of a demo, we'll stop there, as there's more processes that normally would go into approving a pull request. Okay. So that would be the end of the demo. So we'll go into the first Q&A sessions here. Okay. A good question here. How do we deploy a selective pipeline and the related trigger in Azure Data Factory? So Azure Data Factory actually uses a concept called iterative deployment approach. So it's pretty much the basic way of doing this is all or nothing. So you would deploy your whole ADF as all the data pipeline and the related components from one environment to the other. It is possible to deploy a selective set of pipeline. We will have to use the Git process called cherry picking and pick the specific files that you want, and that's not that is going to be a very complex discussions to have for this meeting today. Okay, any other questions there? Okay, so if there's no more questions, we can continue on to the second part of our presentation. Again, there's always a second Q&A sessions at the end if we can take advantage of that there. Perfect. So the second part of our presentation today focuses on how do we utilize the CICD or the Azure DevOps pipeline process to create to help automate some of the deployment processes. So, your boss is pretty happy that we're able to back up all of our source code into Git repository, and you've been working very hard for your boss. So he wants to make sure that he bring additional data engineers to help you continue to deliver the awesome work that you have been doing. So now the team is growing, and there are many different pipelines being built, and different changes are happening all the time. It gets a bit overwhelming, as we don't want any changes that are not ready for production to be published, essentially. So one way to deal with that is to separate the development data factory with the production data factory. And the benefit of that is now everything in production will be much more tightly controlled, and it'll be a separate data factory resources that will prevent any accidental changes from happening. And we can also limit the number of people that have access to the production data factory as well. So, that eliminates some of the access concern. Now, with that, one of the big challenge that we will have is how do we promote the code from our development data factory into the production data factory. So we will do that through the Azure DevOps pipeline. You can automate this process for bringing our Azure Data Factory development data pipeline into the production Azure Data Factory. So as we discussed previously, once we enable Git in the development Azure Data Factory, it actually creates two separate modes, the Git mode and then the live mode. So as you can see on the left there, we're already familiar with that. And the Git mode of the Azure Data Factory is tied to a collaboration branch, and in our case, that's the main branch. So what the Azure DevOps pipeline can do for us is to take the code from the collaboration branch and generate the ARM templates for us, similar to what you saw on the screen when I click on the publish all button. And the second step you can do is also to deploy those ARM templates to the resources that you want to deploy to. So this could be either the live mode from the Azure Data Factory development, or it could be the production Azure Data Factory as well. And finally, we can also set up an approval process or a stage gating process for each of the environment. And as you can see in the screen, we want to set up an approval process for our production environment, as we don't want changes to be pushed out to production without kind of doing all the checking and all the validation and testing. Okay. The last benefit of Azure DevOps pipeline is give us the ability to define the parameter value that we want for each environment. So there could be server name differences, password differences between development and production. So we can all define all of those variables inside the Azure DevOps pipeline. So let's dive slightly deeper, a little bit deeper into the Azure DevOps pipeline process. So in the DevOps pipeline, we will have focus on three primary components, and that's environment, variable group, and the pipeline itself. And in the environment, this is where we will define the development, UAT, and production environment. So each environment, we have the ability to define the different stage gating process or the approval process that we want. In the variable group, this concept is where we can define our variable that to be used in the Azure DevOps pipeline. We can override any environment-specific parameter as well. And finally, there's the Azure DevOps pipeline itself. So this Azure DevOps pipeline can be very complex, and because of that, Azure DevOps provides an ability for us to group the different components together, or different levels of grouping of the how the pipeline needs to run together. So inside there are three different groupings. So at the top level, we have something called stages. So what the stages do is a stage group allows us to group all the major actions together, or that's how we're using it. And in a good example of that is we want to the first stage we want to do is to build the ARM template from the JSON from the collaboration branch, and that is what we would call as a continuous integration or CI stage. The next stage, for example, would be to deploy this ARM template into the live development environment of the Azure Data Factory. That would be a second stage we would do. The next item we have here is jobs. So jobs are defined as something that's inside the stage, and jobs contain different steps. Jobs are actually very important to us, as they are jobs itself is what being sent to the build server to complete the task. So it's important to know that we need to make sure everything inside the jobs it's independent and self-contained. Finally, for steps, so the steps are actually the smallest steps that we have, are the actions that we want to do, we want to take, and we want to do. So for example, retrieving or checking out the source code from our collaboration branch would have been a step. Generating the ARM template would have been another step, and so was validations. Okay, so so here is kind of a view of what we want to do in the demo. So again, we have the development get mode enabled, where all the code is already been saved in the collaboration branch, the main branch. And in our Azure DevOps pipeline, we will define two environments, the development and prod. Just a note that normally there are 3 environments in a traditional software development approach. There's a dev, UAT, and prod, but for the demo, we'll only focus on dev and prod as to make this demo a little bit simpler. In this case, we in our demo, we created a variable group called ADF config. So this ADF config contains all the different variables that we want to that is required in order for the deployment to be successful. So this could be things ranging from the subscription ID that we need to be used multiple times to environment-specific variables that we will have. Finally, we have the pipelines. So in our case, we have 2 different pipelines. We have one DevOps pipeline focusing in building the CI and deploying it into the development live environment. So that will be one pipeline, and then I have a separate pipeline for the production deployment. The reason I kept a separate pipeline for the production deployment is usually we don't deploy every change into production. So I kept that as separate, and the code is very similar to the deployment of the dev pipeline, and we'll kind of highlight some of the key differences that we have there. Okay, so for that, we'll jump into the demo. I see a question raised. Maybe we'll try to see if that we'll try to answer that question. Wicat, you have a question? Okay, maybe not. Okay. So no worries there. Okay, so before we dive into the... Oh, yeah, go ahead.
Yeah, hi, Wilson. Hi. Yeah, thank you. Thanks for your time. Yeah, it was a good session. I have a quick question. Is like, see the Azure DevOps, just a second, please. The Azure DevOps is providing the artifact, we will build and deploy the CICD pipeline for whole applications. How different it is completely from the traditional CICD building through the GitLab CI, GitLab CI, and other frameworks were exactly in the DevOps architecture. So how relevant is completely? What could be the best out of the market? Yeah, that's the quick question. Thank you.
Right. We can address that as part of the demo, but by and large, there's not a huge difference, and you will see some of the nuance how this can be done. Let's say in a different tool like GitLab or like GitHub Enterprise, for example. The main difference is in the deployment. There is a specific Azure build widget that can make the deployment a lot easier. We don't have to script out a lot of the deployment steps or the PowerShell scripts, for example. So there is some automation built in for us to make our life a little bit easier. Okay. Hopefully I addressed your question there, but if not, we'll revisit it again during the Q&A session.
Yeah, I understand. Yeah, it said will be the resource you are using, but it could not be the costly effective on the enterprise level, where many companies cannot be affordable on that cost level to use on the cloud side. But the traditional approach, way of automating with the Jenkins file scripting or some other automation frameworks. So how definitely it suits to the current organization where they're streamlining of microservices or cloud native applications into the different environment.
You can do the same thing, right? You just have to run the PowerShell command instead of the built-in widget that Azure gives you. So it can be easily done. It's a command that it executes, which we don't have to worry as much about. We can cover some more of that at the end of the Q&A if you don't mind.
Yeah, okay. Thank you. Sorry. Go ahead.
No worries. Okay, so before we dive into the actual DevOps pipeline building, I just want to point out the different resource group that we have in Azure. So as you saw earlier, there is a development data factory instance that we have here. From the first demo, we have a database, we have a database server and a storage accounts and so forth. So in here, I just want to highlight and point out that there is a specific set of resources that are in for development, and then we have a similar set of resources that are in production. And in here, as you can see, they all have the PRD, which is the prod name on them, but they are separate set of services. So our goal is when we deploy into dev, we will connect to all the development, key vaults or database or the storage accounts. And when we do that for production, the link will be pointing to the production environment in our link service. Okay. So let's switch over to the Azure DevOps. So the first thing we will do is we need to take care of a few housekeeping items first. And before I do that, I'm just going to refresh my screen. So we have the updated code in a repository. And in this case, we'll focus on the main or the collaboration branch. And the reason is the DevOps pipeline will be generating the code that comes out of the will be generating the ARM template, which will be similar to the code that we see in the ADF publish. So in here, as you can see, there are two separate folders. As we mentioned earlier, all the ADF source code, all the JSON files are inside the ADF dash code folder. I created a second folder called build. So in here, I want to place all my DevOps pipeline or the YAML files, and as well as all the package.json files. So what is a package.json file? So this is the package.json file contains the dependency of a library that that Microsoft has released. So this is the Azure Data Factory utility tool, and this is the tool that will validate our JSON code, generating our ARM template and so forth. So this is pretty much emulating the whole publish all button that you will click in the Azure Data Factory. Okay. So this script is again, it's in my GitHub repository. So this basically is saying that we would need to download this module from npm, which we'll set up in a second there, and we want to make sure that the version is greater than 0.1.6. Okay. Okay, so for me, I added this file directly into the main branch. But for best practice, again, just want to reiterate that it's best to create a feature branch and then merge it back into the main branch. Okay, so the next thing we'll look at is the environment. So that's under the DevOps pipeline environments. So in here, I have already created two environments, the dev and the prod, and it's as simple as clicking the new button and filling in the name of the environment. And so the one thing that we want to do here, as we saw in the PowerPoint presentation, is we want to set up an approval for when we deploy things into prod. So we will click on the prod, click on the ellipsis here, and we can set up the approval and check process or the gating process. So for me, I'll keep this simple for the demonstration. There could be a lot of different validations and check that we want to do, but for me, I just want a simple approval, and I'll be the one approving the pipeline that is being built. So there are different configurations that we can do. For example, in here, I can change it so that if the CICD pipeline ran or the deployment pipeline in production ran wants to run and are waiting for approval, and if the approval we did not receive the approval in one day, that build itself will fail essentially. Okay, so we'll click OK on that. Okay. So this is how we will set up the environment and the permissions there. So the next item that we'll talk about quickly is the variable group that we talked about earlier. So we can access the variable group through libraries, variable groups. And as we mentioned in the slide earlier, ADF-config is it's set up as the variable group. So in my case, this variable group is broken up into 3 different sections. I have the common sections in the variable group, the configurations that I need in the development and in prod. And later on in the demo, we'll talk about how I retrieve each of those values and where do I retrieve them from. Just want to make sure you guys are aware that there is a lot of variables that we have. It is possible to work with multiple variable groups within a DevOps pipeline. So a common best practice is we would have a common ADF variable group, a dev variable group, and a production variable group. And what that allows us to do is to reduce the amount of changes that we need. So we don't have to fix, we don't have to correct the prefix that we have essentially. So this will be just called ADF location if this is a dev specific variable group. So in the demo, I just want to keep it simple, not work with too many variable groups as you can get confusing in a hurry. A few things I would like to highlight here is we have the subscription ID here. So I locked this variable group, this variable to becomes kind of like a password, so you cannot really see the value of it. But in our DevOps pipeline, you will be able to decode it properly. Okay, we have things like resource group name for the Azure Data Factory and the Azure Data Factory name. They all kind of enter in here to just reduce the number of changes that we need to make in our DevOps pipeline. So you can create additional variables here if you need, as simple as clicking add here. And it'll be done just like that, and it will make a save on that. Okay. So now we will dive into the actually creating our first Azure DevOps pipeline. So as you can see here, I already have the deploy production pipeline in here, as we will review that at the end of our demo. But first, we need to create the build/deploy dev pipeline for our dev ADF first. So to do that, we'll click on new pipeline. We will select the repo Git. Again, the repository that we're using is demo. In this case, we will just select the starter pipeline. Okay. Okay, so this is the starter pipeline that Azure DevOps give you. So I'm going to slightly replace this with a template that I kind of have on hand. So in here, I'll go over each of the components that we have in here. Oops, sorry about that. Okay. So the first thing I want to do is I want to make sure I save this YAML file into the right place. So I'm going to just copy out the YAML name, file name, and we want this to be under the build folder. Just copy and paste the name in. In a bit, we'll change the pipeline name, but we'll go over each of the components here one by one. So for trigger, normally, as we talked about the collaboration branch, once the collaboration branch has changed, we want to make sure we kick off a build and deploy it into Dev Data Factory. For the initial part of this YAML file, we would just comment out this trigger and use none for now. So what that means is we will not actually trigger anything for now, as there's quite a bit of code that we need to talk about. So I don't want every save to be triggering a build, right? Because there'll be quite a bit of fail build in that case. The next item we have here is called pool. So pool, in this case, you just have the VM image that we want to use. If you have your own build server that you want to use, you would you will have to set it up in the pool as well in here. The next item is the variables, and we saw part of this earlier where we're using the ADF config group. It's feel free to have more than one group in here, as long as the variable names are not colliding with each other. And I also defined two other additional variables. So in here, there's the dev subscription ID, the ADF resource group name, and the ADF name. All those variables are being read from the ADF config. Finally, we have this ARM template directory where when we generate the ARM template, we want to put the ARM template into this specific directory. And for this, we're using a system predefined variable. So what that means is a variable that's defined by Azure DevOps called pipeline.workspace. So it's a workspace that a folder that they provides us to write output things, whatever we want to do in there. So any pipeline will get their own essentially workspace. The next thing we have here is the stage, as we talked about. Our first stage is the building the ARM template stage, and the second stage is the deploying of the dev ADF stage. Okay, so for now I commented on the second part because or else there will be a lot of errors. So we'll go step by step through building out this YAML file or this DevOps pipeline. Okay. So for now, there's a jobs that we define here as just a refresher. Jobs is what is being sent to the build server, and we will fill in more of this code in a little bit here. So before we do that, we're going to first save this YAML file or this pipeline. Okay. Again, not the best practice to save directly into the main branch. Normally, we would do this through a feature branch. Okay, all right. So yeah, we fully expect this pipeline to have an error as we didn't define really any jobs underneath the job flag, which is fine. But before we go any further, what we really want to do here is we want to rename this pipeline. So right now, this pipeline is called demo, and we want to rename that. So we can click on the dot on the or the ellipsis on the right, click on rename or move pipeline, and all we're doing is just renaming this pipeline. We're okay with the folder where this pipeline is sitting in. All right. So with that, we'll go edit and go back into the pipeline to make more changes. And as you can see, because we disabled the trigger here, there was no build that really took place. So, which is exactly what we want. Okay, so I'll paste in the first 3 jobs here that we have. So for the first 3 pieces of the code that we have here. Okay, so I will step through each one of them just to make sure everyone understand what's happening in here. So the first job that we have, so in this case we only have one job, and the job is to build the ARM template. The first thing we do before anything else happens, we want to make sure that our workspace is clean, and what that means is to ensure that the workspace do not have any previous code that's built in there or checked out, anything from previous build that might be still remaining. So we want to make sure everything is deleted and cleaned up. The next thing we would do, the next step we would do in this case, is we want to check out the source code from our repository. So in this case, when we run the pipeline, we will define the checkout branch to be main, which is in this case represented by self, and we want to put put this into a specific path. Essentially, this is the workspace path that we would use. Okay. As we mentioned a little bit earlier, we are using the Azure Data Factory utility. And in order for the utility to work, we have two things we need to do. We need to install the Node.js tool, and as well as the npm package. So as you can see here in the npm package, what it needs is to look for the package.json file. So we pass in the build path where our source code, when we check it out into the build, this is where our package.json is. Okay. So the next step we will do is we would use the MMP package or the ADF util package, and we will want to make sure that we validate our code, like what we talked about earlier. So in this case, we have a task that will validate our code, and we will execute this run build command. Now, since the ADF package, the npm package is available by all the other build services, right? It's a public repository. This can be ran, in any other, like GitLab or any like Jenkins and things like that. So all of this command here, this two command to validate the code and to generate the ARM template, those two pieces of line of code are available in all different build servers or build tools. And as we mentioned before, in Azure DevOps pipeline, we have this concept called publishing artifact. So what this does is actually packaging and creating a build zip file for us. So and this zip file will be used, this build file or the zip file will be used to deploy into the dev ADF environment and as well as in the production environment. And this zip file contains the ARM template that we generated earlier. So if we take a look quickly in the code, when we generate the ARM template, we set the ARM template output path to be under the build. And essentially, this is where we're grabbing the files from a subdirectory that we created from the ARM template name. Okay, and then we provided the same name as the artifact's name, and then we publish it as a pipeline. So this step probably will be different, depends on the type of build server you're using. But yeah, okay. So in this demo, we will save this. Okay, for publishing. Okay, and I will also run this. Okay, so again, this is where we're running. We're running off the main branch and not the any other branch that we have. So we'll click run. So this is the build that's happening in place. Click in here. Okay. So this sometimes this is a specific thing for Azure DevOps. We need permissions in order to run certain access. So in our case, we need to grant access to the ADF config variable. Because I'm an admin in this project, I can do this by myself. But in an enterprise environment, there might be different permission needs to be set, or someone else need to help grant that permission. Okay, so let's take a look at this quickly. We did a checkout of our code. No strange error there. We installed the Node.js like we talked about, as well as the npm packages. Okay. And we validated our source code using the Azure Data Factory utility package. Okay, generate the ARM template. Oh, let's see here. So we notice there's 2 errors here. So there's a feature inside Azure Data Factory where we can customize the ARM template that we get. And in our case, since we didn't customize the ARM template definition, this is just a warning error that we got. Nothing actually failed in our case. It's a feature called custom parameter that I can show you quickly where you would change to that if you were to do that. So, first demo under manage, this is ARM template. You can customize your parameter configuration. This is not something I would go into in this demo, but this is something that can be done. And that's what this area is related to. Okay, so it's important that we take a look at the publish ARM template. So there's total 8 files being processed and it's being uploaded. So we're going to take a look to see, take a look at the artifact in just a quick second here. Okay, so it looks like everything ran successfully. There was no error. So when we go back to the build, okay, this build number here, we can see there's 1 item being published. Okay, so when we look in this publish, this looks exactly the same as what we have in our ADF publish branch. We have our parameter file for the factory, and then we also have the ARM template for the factory. Now let me bring up Visual Studio Code, and let's take a look what the code looks like in here. Okay, so in here, this is the template for Azure Data Factory. Again, this is the compilation of all the JSON components that we have inside Azure Data Factory. And if you happen to define a self-hosted integration runtime, this will be included in here as well, or any other runtime that you create. And the second file is where I want to focus a little bit of time talking about, and this is the parameter files. So you saw here there is the data factory name. This is the sales database connection string that we have set up in the link service. It's important to note that we did have a naming convention for our Azure Data Factory, so we can easily tell this is a link. This is coming from a link service by the definition of LS in the front, and the TR is the trigger that we have. So this is the data lake property and key vault and the weather service property, etc. Okay, so for now, we will. So what we have done is we would define all of these variables. Not all. I think we defined the 4 variables here because they will be changed between development and production. The weather service, we're just gonna assume that it doesn't change as it's a file that I made available, and then in the trigger, there's nothing that are environment specific. It's a definition of how do we format the datetime. So there's no changes there. So for now, I'll go back into the Azure Factory, Azure Data Factory dev, and take a look to see how we can fill in those values here. And those values will be what we put into the variable group. Okay. So in our case, since everything is under link service, we know that we can just go to the link service tab. And if you mouse over each of the components here, you can see the little curly brackets. So for example, the data lake, when we click on the curly brace, this is the URL that we're given. So this is the URL that we will be putting into our variable group to override the defaults if we need to. Now, as we saw earlier, everything has a default except for the sales database. So when we click on the sales database, the connection string is actually contain some of the private information, like it contains a server name, it contains a username, and the catalog that you're accessing the Azure SQL on. So this is defined as a secret, I guess, if you will, or secret string. So that's why there's no defaults for it. And we created this value as a secret as well in our variable group. Okay, so that's how you would find all the initial value that you need for your ARM template to be overriding or creating the variable based on. It's strictly based on this parameter files here. Okay. Now let's go back to the DevOps pipeline for a second here. Now, with all that information, you're able to finally create and finish your variable groups, all the information that you need there. So the next thing we will do is we will complete the pipeline by finishing the last stage that we have, which is the dev deployment stage. Okay. So we'll go back to the pipeline and we'll go edit. Okay. So as you can see here, just a second here, the stage here is indicated there's only one stage, only one checkbox here. So in our next build, there will be two. Okay. So we'll go edit. And then I'm just going to hide this task thing on the side quickly here. Now uncomment the code for the deployment stage. For the deployment stage, we use a very specific type of job, and that is the deployment job. So the deployment job, it's similar to the task, except that it's specific for deployment purposes. It has different strategy variables, strategy definitions of what we want to do. There's a pre-deploy step, and then there's a deployment step. But in our case, we're only using the deploy step. Now, one thing I just want to point out before we dive into that piece of code there is we define a depends on variable here to say that this stage can only start after the build ADF ARM stage is completed. So we cannot jump ahead without the build being completed first. So the next thing that the deployment job gave us was the environment variable. So in the environment variable, in this case, I'm defining using the dev environment, and later on in the production pipeline, we'll use the production deployment environment. The benefit of this is, like I mentioned earlier, there's different gating process that we set up, none for the dev, but in the prod there is. So the build will not be able to proceed if there's a approval required. So you will kind of stall waiting for the approval, and then once we get the approval, then you will continue on with the pre-deployment or the deployment steps. Okay, so again, there's two tasks in here. The first task is to download the pipeline artifacts that we created in the previous stage. So this is very specific to Azure DevOps, might be different in different build servers. Or the different build services. We grabbed the artifacts from the build that we just completed, and we output into the directory. And what I like to do here is actually to list out the files that we retrieve from the artifacts, so we know what files we're working with. This is a good items to have for debugging. If you don't really know what files you have, might be quite challenging to debug your deployment problem. Okay, and the last step here is this is the Azure Resource Manager deployment template deployment task. This is similar to the PowerShell command you will use to deploy the Azure services. In this case, we need to specify the subscription ID. What do we want to do to the resource group? We want to create or update resources, the type of resource name that we have. And I want to point out three primary items here: the CSM file, this is the ARM template files that we have. The CSM parameter file, this is the parameter file that we saw, right? That has the 5 or 6 different parameters. And finally, the override parameters. So those are the parameter names that you saw earlier in the ARM template, the factory name, the ls sales database connection string. Those are all specified to be overridden in here. Okay, and which is why we want to create a variable group so we don't actually have to type in all the values in here in case the value ever changes. We can just go update the variable group, kick off a new build, and everything is good to go. So with that, we'll save our code here. And we will also run this code. Okay. Let's swap back. So this will take a while to complete. Okay, so there's a question about self-hosted IR. So there's two type of I assume that when you talk about self-hosted IR, you're talking about the Data Factory self-hosted IR. So that's defined in the Data Factory integration runtime. Again, this is the production environment. I don't have any code in here at the moment. I forgot to show you guys that in a previous step. But in dev, you can define all your connections here, and most likely you will have to override some kind of a parameter or settings, as you might have a separate integration runtime between prod and dev. And if not, then you don't have to override that. But if the question that you have was more related to the self-hosted build servers, that can be configured in DevOps. So just going to come back to the demo really quickly here. There's two permissions actually need us to grant. The first permission is the development permission, which we'll grant it because we're using the development environment. And then the next one is the service connection. So a service connection is what we grant. It's a service principal that we created in Azure Data Factory in the subscription that we granted the access to be able to deploy resources, or by extension the contributor access. So we will grant the access as well. Yeah, so you can go into the project setup. It will show you different agent pools. So for me, I'm using Azure Pipeline for deployment, but you can also use define your own agents as well if you want. But that's kind of out of the. We're not really gonna deep dive into the specific of the administration part of the Azure DevOps. Okay. So let's take a look at our second build. Looks like the first stage has already completed, and we're in the deployment stage. So we'll come into here. Let's take a look to see what's happening. So let's take a look at the artifacts that we have. So we first have downloaded the artifacts. So looks like 0.2 megabytes was downloaded. Okay, and then we list the files here. So looks correct. There are 6 files for us. That's what we saw in the VS Code. And now you can see that the deployment has completed. Now, just a reminder, this is deploying to the dev deployment. We shouldn't expect to see any surprises. Now, a good way to check to make sure your deployment is working is to bring up your Azure Data Factory. And since we did overriding the parameter, we want to make sure we double check all the parameters that we overridden. And we will be doing that for both dev and production. Okay, so let's take a look at the data lake. So the data lake URL is still kind of intact. Nothing happened to it. The key vault here is still working as well. So it looks like our deployment did go through successfully without losing any of the without corrupting any of the link service that we have today. Oh, actually, my mistake. We should be switching to the live mode to do this check. So again, that's under the top here, select live mode. And I'll actually just do a quick refresh to make sure we are in the live mode. Okay, we'll double check this again one more time. Okay, everything looks okay. So sounds like our script is running perfectly good. With that, our deployment is working now. So we'll touch on the last bit of the demo, which is the production pipeline. Okay, so before I go into the production pipeline, I am going to just enable this pipeline for now, because I was disabled at the beginning. So in this pipeline is slightly different than what we have done in the dev deployment, because we don't want every development change to get promoted into, let's say, the UAT or production. And there's a mechanism to do that in Azure DevOps pipeline, and this is through the resource pipeline trigger mechanism, which is slightly different than the basic trigger that we use in the dev in the initial CI and the dev build. So in this, we can specify the source pipeline that we want to depend on, and this is the build deploy dev pipeline that we created a little while ago in the demo. And we only want to trigger a production build if we pass the last stage, which is deploy to dev. And this particular pipeline, the build has the production tag on it. Okay, so what that means is we will have to swap back into the other pipeline in a second, and we will be tagging the build for production, which will then in turn push that deployment out to the production data factories that we have. Okay, all the code that you see down here are exactly the same as what you saw earlier. So there's no changes, no dramatic changes here. Of course, this environment is prod. The one change that we have is we do not have to use the download pipeline artifact. Instead, because we defined the resource pipeline already, this particular pipeline knows that there's an artifact that we want to download automatically. So we just need to say download the pipeline name that we specify up here, and this is the artifacts that we will be getting. Again, we want to list the files that we have, again, to make sure there's no, we're not missing anything. And then in this case, we'll be doing the deployment to prod. And what I did here is updated all the variables to be prod instead of dev. Again, if you would have two different variable groups, you might not need to change any of this if you have a specific dedicated prod deployment group, a variable group. So for me, I just reuse the same one. Okay. So I will not start this pipeline in any way, shape, or form, because this should be automatically starts once I go into this pipeline. This particular build, I'll click on the ellipsis and add tag, and then I will type in production, and I'll save. Okay, so now this build has a production tag, and you will use this particular set of files to deploy into prod. In case if you have multiple builds, you will only use the specific file. Okay, so let's see here. Did we not? How happened here? Didn't seem to get triggered correctly. Okay, double check production. Okay, let me just kick off another build here really quickly. That was a little weird. It should have been. Should have picked up the change. I'm just going to double check a few things here. I just want to make sure I got all the names correct, because this is very, very name sensitive in this linking the two files, two locations together. Dev pipeline, that looks correct. Okay, we'll give it one more try. If this doesn't work, then we'll just kick off the pipeline manually. Something funny is going on behind the scenes, so. It might be caused because how I paused the pipeline and never restarted it. Thank you, shown that. But regardless, let's get this double checked. Okay, deployment is done. Okay, oh. Again, come in here, mark the tag as production. See if we have any luck this time. No, okay. So I'm not too sure what might be going on here. I'm just gonna kick off the run for now. Maybe something funny on with when I disabled the pipeline earlier. Okay. So again, this deployment would need the permission for the prod environment. Okay. And now when we come back out, we should see now there's approval that's required for this build, and this is the prod approval. So it's waiting for me to approve. So I'm just gonna, you can see here it's for dev. I will approve this. And now we wait for this to just finish running. Okay. Again, just double checking, downloading the artifact, listing the file to make sure everything is good. And we can see in here when we download the artifact, there is an ID that was provided, build 84. So if we look back in the dev deployment, we can come into here and we can see that build 84 is the one that we grabbed the build from, which has the production tag on it. Okay. Yeah, we did the deployment and it finished. So it looks like there's no error there. So we'll go into the production data factory in this case. Let's do a quick refresh. And we'll go into the author mode. As we saw earlier, there's nothing in here. So now you can see all the pipeline and all the data sets that we have. Again, since all the parameters are all in the link service, we want to double check that again one more time. So we can see this prod here for the key vault. We'll double check here. It's also prod, and you can click on the actual item. It will tell you it's prod. It's the same thing here. Okay. And in here as well, we can see this is the prod server that we have with a prod database that we have. So yeah, so that's pretty much wrap up the demo for the deployment, and that's how we would deploy into a separate production data factory. Okay. So after all of this, so today we learned that how we can integrate Git with Azure Data Factory to protect our source code. Azure Data Factory has two mode. There is the Git mode and the live mode, and there's distinct differences between the two. And it's important to know when to use which. And we are able to deploy the Korean Azure DevOps pipeline to automate our ADF data pipeline deployment process. That include building and deploying into our ADF in the live mode using CICD. We learned that now we no longer need to push the publish all button in order to publish our code. We set up a gating process or stage gating process or approval process by environment. We should be able to automate the trigger for the production deployment using tags, and I'll take a look a little bit more on why that wasn't working offline. And finally, all the code you guys just saw in the demo, they're all available in the GitHub repository that I have under the demo/ADF. Okay. So with that, we'll jump to the second Q&A session. We can. Okay, if not, maybe Gopin, do you want to start us off? You guys might be talking on mute. I don't hear any of you guys talking. So.
Hello.
Hi.
Yeah, hi Wilson. Yeah, I have a quick questions. Like, the Azure DevOps is the practical way of implementation through the YAML file structure, and how does it happening the incremental bidirectional builds and deployment cycle? Because let's say I'm working upon the cloud native application, I have my dependent. We are going to add those dependencies to create the application packages and deploy into the AKS.
Sorry, unfortunately, I'm not an AKS expert, but I do believe there are specific set of AKS tasks that are used to manage AKS deployments. Most notably, I think the difference between the incremental versus the other mode is the complete mode. The full mode is essentially in the full mode. Azure DevOps basically treat everything as deleted and redeploy from scratch. So it's slightly different that way. Yeah, where incremental, they try to make changes only.
Yeah, how you are measuring the risk on the development deployment side in the same, like, I have the microservices, the application set, and I want to do some, the failover strategy or the rollout strategy. They want to do any BG deployments and to check the test accuracy upon the application framework. If there is a Java to achieve through the Azure DevOps.
Yeah, so I'm not an expert in Kubernetes, so I couldn't say exactly how that would be done in the DevOps. But I do believe there are dedicated tasks that you can look into to revisit that.
Sure.
Yeah. Okay.
And I believe, let's a quick final question before I wind up. Yeah. Azure DevOps is a resource costly on the cloud side, but I could see GitLab CI also provided the user-friendly open source. So how effective for the current enterprise companies to choose only Azure DevOps, not for other system? Yeah, for automating. Yeah.
So it depends on your Azure on your cloud environment, I guess. If your Azure if your company is Azure focused, then obviously Azure DevOps is much more easy to use. I'm not too familiar with all the different pricing model of different SaaS vendors that they have, but a lot of them are charging by users, or like thousands of users are bucketing together. So I haven't done the price comparisons, but based on my understanding, a basic user are relatively cheap for it to use. And if the price really runs up because you guys or your organization uses a lot of the cloud Azure provided build servers, you can host your own as well to manage that cost with various different agreement with Microsoft. So there could be many different pieces that can help with managing that cost. Okay.
Yeah. Thank you.
Yeah. So how do we revert the second last deployment of the code? So you were referring to the production deployment. Then what we would do is we will have to re-execute the pipeline that got deployed, that was deployed into production last. So for example, if we deployed build number 1 into production, and then now we deploy build number 2 into production, if we want to revert, we have to go find the last build then and basically kick it off again.
Hi Wilson, I have a couple of questions.
Sure, go ahead.
This Gopinath. So my first question is like when we are doing the deployment for Azure Data Factory, we are following the classic approach like create a build pipeline. Then after that, we'll create a separate pipeline in under the releases folder. So now in this approach, we are calling this new approach. So in this approach, we are used to have it like a YAML script everything. So what is the benefit between using this classic approach and the new approach, Wilson?
Yeah, that's a great question. I like the classic approach more personally, but I think a lot of, from my understanding and the documentation, a lot of the classic release processes, they're soon going to be deprecated or will be deprecated. So and they have made a whole bunch of improvements in the new DevOps, the new pipeline deployment process. So probably it's a little faster. But I think a lot of the traditional release process, I believe you can click into the task and actually get the YAML out of that, and then move into and then move it into the modern pipeline of executing. So I think I think it'd be a good idea to start moving into the new way.
Okay, so this is applicable for all the services, right? So like not only for ADF, it is for if I'm using Azure SQL DB and application web application. So for everything, it is applicable, right? So this new approach.
So anything that so that's a service as a whole. There are in the documentation they talked about some of the release processes are going to be retired in the future. So so it's not specific to ADF, but I do not know exactly which one will be retired. As the list is, I don't have the list in front of me.
Sure. So I have another question. So like in this YAML script, if I want to update the global parameter, so what is the approach? What is the steps we need to handle in this new approach?
So it is recommended to not use the global parameter file that comes with the generation. It is a documented problem that if you use this script, it will sorry, let me rephrase that. It is documented that like you don't want to override you want to use the PowerShell this script to override the parameter, and not use the parameter method of overriding the parameters. So not the global parameter.json file, but use the PS1 file. There's a well-known issue that if you use the JSON file, you might break some connectivity with, let's say, Azure Purview, for example. So execute the PS1 file essentially. It's a short answer. Yeah.
So one final last question. So so we have that variable group. If we have a different variable group for different environment like dev, stage, and production. So in this YAML script, if I want to have within a single YAML script, if I wanted to have a different stages for each environment, for using this a different variable group. So is that possible within the single YAML file instead of going with a separate YAML file for each environment?
So you can have your CI and your CD all within one YAML file if you like. That's not a problem. Within each of the stage here, you can specify your variables as well. So let's say if you want, if you have a dev variable here, right, and then below in your other stage you can have a separate variable as well, right? You can have a prod variable here. So that can be all done as well. Yeah.
Yeah, thank you so much, Wilson.